Hey, good afternoon, everybody, and welcome to TGIK episode number 108. It's very good to see you all. Let's see who you all are. Remember, I always have my screen off to my left here, so if you see me like casting my eyes about the room, that's basically what's happened. But my chat, the way I can actually see your interaction is always to my left, and that way we can save the desktop screen for the fun stuff like going through the articles and that sort of stuff. So we got Martin from the Netherlands, we got Rory from Scotland, we got Waleed, good to see you, Waleed, and we have Marky Jackson, totally awesome human. If you ever get a chance to hang out with Marky, highly recommend it. Actually, I think that's true of all of the people in the list so far. I mean, these are all amazing people that I have met and enjoy their company. Raiko from, good to see you, and we have Joe tuning in. We got Amine from Strasbourg, we got Miguel from Mexico, we got Peter from Seville, Spain, we got Tim Reese from Frankfurt, and Tim Downey. We got Morteza from Tehran, and Eric from DFW, and we got Lamati. Thanks for coming back-to-back weeks. Oh yeah, I'm digging it. They do take some preparation, but it's fun, you know. It's like fun to kind of explore this stuff, you know. We got Amin from Amsterdam. Is it Amin or Amin? I'm not gonna. I mean, like, how would you actually answer that? That'd be kind of a tricky thing. Anyway, we got Ilko from Holland. Good to see you all. All right, so let's dig into the news and see what we got here. We got Alejandro signing in from Lima, Peru, and let's flip over to the screen and face. All right, here we go. So this is this week's news, and again, like as always, these things are available online at tgik.io/notes, and it's actually linked at the very top of the chat. So if you want to, help keep track of notes, or if you see me discussing a link, or if you have some context or reference link that you would like to share, feel free to throw it in here. This week in review, we got 118 beta 1 is happening, right? So that means we're getting pretty darn close to the 118 release. The sidecars kept, which actually raised a little bit of news this week. Let's talk about that one. That's a fun one. So 118 is almost there. Sidecars kept. This is a really interesting enhancement, and I'm afraid that the author of this enhancement lost a little faith this week because it was taking a while to get this done. But it is a really interesting one. So this kept is basically the idea. Let's see if it is like the next, yeah. So this one's this is the release sign off. This is not the KEP. The KEP is probably linked from in here, but this is a relatively, there we go, boom. So this is a relatively new idea, and it describes a different way of thinking about sidecars in that, and I like that there's one line in here that really succinctly lays it out. And this is basically what the change in behavior would look like if KEPs were to, if this KEP were to be implemented. And it's currently in implementable phase, and there's an author working on it. He's done a lot of amazing work, and I hope it does get in, but it looks like it'll probably get in 119. But the thing that it would do is it would allow you to indicate that the life cycle of one of the other containers inside of your pod, right? So you might be able to indicate that a given container inside your pod is lifecycle type sidecar. And when that happens, it changes the normal startup and teardown a little bit. The init containers piece is not related to this. The init containers still start before other things can start. But then we see sidecars starting before anything not labeled sidecar. Sidecars become ready, and then containers start. And this way we could do things like, maybe have a sidecar lifecycle that is responsible for managing going to fetch secrets from Vault, right? You would kind of want that to actually be in a successful state before you started your application. And this allows for that sort of a mechanism. The interesting thing is also that it works on the way out as well, right? So when the pod is getting ready to be terminated, it'll send a sigterm to the containers, and then once all of the containers have exited, sidecars get a sigterm. So if you're running that lifecycle model where you have another container inside of your pod that is marked with lifecycle sidecar, you'd be able to see that it would start first and it would become ready. Then your regular containers would start. Then on termination, the regular containers would get the term. They would end. I mean, they would leave. They would exit, presumably, and then the sidecars would actually get the the exit. And this might, that might be useful for things like log forwarders and those sorts of things, right? Like things that need to actually flush a buffer or flush to disk before they can actually sign off. So there's some pretty good reasons for doing this, and it looks like it's actually hopefully going to happen in 1.19. So that's a change that's coming. I thought that was actually a pretty cool one. There is another one. Please remove Bazel from. Please remove Bazel build based. Wow, that's a hard one to say. Please remove Bazel based build infrastructure. And what that does is it will. And what that will mean is basically that the. Give me 1 second here. Okay, so what that will mean is that right now there's actually a number of different ways to actually build Kubernetes, and we tend to use a couple of them, right? So there's at least 2 different ways that are in heavy use for actually managing the build of Kubernetes binaries and all of the testing and everything. In some cases we use Bazel for everything. In some cases we use helper scripts and those sorts of things to do it. But what this represents is, because there are 2 of them, that is like twice as much work to actually to bring together a given release. And so in this case, the argument is, well, if we're going to nuke one, which one should we nuke? And which one are we getting the big value out of? And what are we not seeing? And this is actually one of the things I really dig about the community, is that this issue is raised and everybody's coming to it with an open mind. Like there's no like immediate naysayers. They're really like coming in and saying like, if we do this, here's the fallout that I could see, right? And people providing support, and people basically making sure that we go into this, a decision like this, which is pretty critical to the build infrastructure, with our eyes open. We really want to make sure that like we don't miss anything. So let's go back to our chat, see how everybody's doing. I am using Ubuntu. We have Tolgahan from Turkey. We have Shahar from Atlanta. Good to see you, Shahar. We have Joy from, how you doing, Joy? And we have Balaz. What Linux? I'm using Ubuntu, and I'm using like a version of Ubuntu that still gives me wobbly windows. It's kind of fun, because I'm just that kind of Linux geek, We got Gustavo from Chicago. We got Rachel saying hello. And we got ABC123 from the Bay Area. Good to see you. Mohammed from Paris, and Marky is really on board with the removal of Bazel. You got Mike saying hello, and Marco saying hello. Yeah, I think Marco's also on board for that. What else do we got here in our news? We have establish, let's see, the next one up is a full checklist for K8's infra, and moving official images into a community-controlled resource, which is on track for April Fools, which I think is interesting. I think it's kind of a funny time for that to happen, but I think, funny as in haha, not funny as in weird. So this is, where's that at? Oh, I guess I didn't link it. All right, so what that means is that right now, most of the images that if you're going to pull container images for Kubernetes components, like the controller manager, the scheduler, the API server, all of those things, you would actually get them from k8.gcr.io, which is a vanity URL in front of a GCR repo. And that has, up until I guess April 1st, has always been the ownership of that has been Google. And so what this represents is now the community will have the ownership of that repository, and that's pretty cool. It's again kind of what we're seeing is that like Kubernetes is kind of coming out into the community as far as like all of the resources and components that it needs, and Google has been incredibly generous in offering up quite a lot of that infrastructure at no cost to further the project, which has been tremendous. But this actually pushes the ownership of some of those resources into the community hands, which I think is again just an incredible sign. I think it's really good stuff. What else? I think we have the next part is the sad news. All right, so the sad news is you have probably already been made aware of this, but if you have not, it's actually not just KubeCon either. So KubeCon Cloud Native Con in EU has been postponed. So the one that was to happen in Amsterdam coming up here at the end of March. It would have been March 31st to April something. That has been postponed. The final dates have not yet been picked. The North America event, which was scheduled for November 17th to November 20th, will continue to happen as it was scheduled. And unfortunately, also the Cloud Native Open Source Summit in China has been canceled due to not enough interest in that particular event given the current circumstances. So big changes, like obviously that means that a ton of us are not going to be in Amsterdam at the end of March, but hopefully we will be there later in the year. So the goal, I think, is to be, right now they're going back and forth between July and August, or maybe some crossover between the two, but I think that's actually the goal. There's been a survey that has gone on around it. The CNCF has been super responsible for making sure that they get information out as quickly as they can, and also trying to make sure that they make the right decision for everybody in the community. Like, your health is obviously incredibly important. And I'm really glad I have y'all to go chat with, because I imagine that many of the DevRel folks, and my heart goes out to them, like a lot of the folks that actually spend a lot of their time out there with talking about things and working on conferences and building talks and those sorts of things. I can imagine this would actually incredibly adversely affect them, right? Like, a lot of the conferences have been shut down or maybe turned to virtual, or canceled or postponed, and that means that a lot of folks that are working in this space are going to have a hard time. So that's what I know about that, and obviously more of that will, I'm sure, probably surface by next week, and we'll have a little bit more of an update around what's happening there. Contributor Summit for Amsterdam has been postponed. Obviously, a lot of the 0-day stuff will actually also be postponed or turned to a virtual event. What else do we have here? All right, well, that gets us into our docs. I feel like we missed something. Okay, so there were actually a couple of the things that George found, which I thought were pretty interesting. So let's go ahead and pop these open. So this is an interesting one, and it kind of reminds me a little bit of K9S, right? But this is a framework that you can use, or a plugin, depending on what you want to do, to actually interact with the Kubernetes services. Very similar. We've seen a few of these in the last few weeks, but this one is actually kind of neat because it is just a framework for graphical terminals. So its goal is not necessarily to really pin the experience on exactly what you want to see, but to allow you to kind of develop your own thing. And it also blurs that line between a text UI or a TUI and a UI or a GUI, right? So in some cases you can actually pass an argument like kubectl GUI get pods -UI, and it will pop open a little window with your output. Now I haven't tried this out to see if it's cross-platform, but it looks like it's built on Electron, so it might be kind of fun to try that out. And maybe we'll try that out in a little while, but that's a new one that's come out. Jeff Geerling writes, everyone might be a cluster admin in your Kubernetes cluster. Gosh, I hope not. Quite often when I dive into someone's Kubernetes cluster to debug a problem, I realize that whatever pod I'm running has way too much permission. Often the pod has cluster admin role applied to it through the default service account. Yeah, that's a problem. That should not be true. Okay. So what that would mean is that somehow, somebody has actually created a new cluster role binding of cluster admin to the default service account. And as you already all know, every pod in a given namespace will be associated with the default service account inside of that namespace. And so if you do that, then that means that any pod that could land in that namespace would be able to inherit that service account and get that permission. And so I think what he describes here is actually a totally reasonable thing, but it looks pretty fun. It looks like he's got some examples for how to check it and see if it's actually a problem, like how you can actually break out and do things the way you might be able to actually evaluate whether you have cluster admin or not. One of the other ways that you can do that, and I think I've talked about this before, but let's actually pull this up. I'm going to kick over to another screen here. You can also do this command, kubectl auth can I --list. So you can impersonate an entity, like in this case, if I do system service account default. If I run that command, then I'll actually be able to see what permissions that service account has against the system. Now I don't have a cluster up right now, so that command's not going to do anything. But I did want to show that to you. Like that's another way of actually determining whether you actually have too many permissions available. What else do we have in our chat? All right, so that was that part. Kubeflow has hit 1.0, which is an interesting one. It's an cloud-native ML platform for Kubernetes. And this is actually, I mean, if you're into like machine learning and Jupyter networks and TensorFlow and that sort of stuff, it's actually pretty cool. They've got a pretty reasonable way of actually deploying this stuff on top of Kubernetes. So if that's a thing that floats your boat, definitely go check that out. But they've hit 1.0, which is a pretty reasonable milestone for them, and that's pretty awesome. Spotify has released their Terraform GKE Kubeflow cluster. So if you're in GKE, or you can actually manage a GKE cluster, you can actually spin up Kubeflow the way that Spotify does and play with those things, and that's pretty fun. Kind of related, I think that it was all, yeah, Kubeflow. Yeah, speaking of Spotify, so that's actually, I think that's the Spotify team working on that, and they've open sourced their stuff. So then we got Vault replication across multiple data centers on Kubernetes, which is a mouthful. This idea being that you could replicate vaults. I see. So this is actually from Bonsai Cloud, who has done quite a lot of work in this space. So they have a vault operator and a multi-data center setup. And they presumably have a way of syncing vaults from one vault to another across different clusters. So they've got multiple clusters in different regions. After all the clusters are there, you need a kube config from each. Then you have bank vaults repository, holds a useful script. Oh, nice. Which actually probably does all the heavy lifting, copying vaults and content over between different vault implementations on different clusters. So that's actually pretty cool. I might want to try this out in like a TGI. That'd be kind of a fun one. Next we have Kubernetes namespaces. I haven't seen this video, so I don't know if it's great, but it looks pretty awesome. So I think I should try this one out. But like Kubernetes namespaces are a thing that is like constantly under discussion. Like, what would you put inside of a namespace? What should be inside of a namespace? Like you know, namespaces are where we define constraint, and so because of that, when we think about like how we use that primitive, things get a little complex, right? Like if you're going to actually use a cluster to grant individual users access to a namespace, like namespace as a service, is that one namespace per person? And then when you do that, like what actually goes into that namespace by that person? What is the spinning transition? Oh, you mean this thing? That? Oh, I'm using Linux. So this is happening because I have Compiz going. And so I can see the gears running in there and like all that fun stuff. Okay, CRDs killed the free Kubernetes control plane. This is some conjecture, but I thought it was interesting. So in this one, they're talking about how Google is actually now charging for control plane nodes, and they're making the statement that maybe the reason that is because there are a lot of people who are using the control plane nodes to hold data. So. But it is an interesting read. So if this is something that's interesting to you also, definitely check that article out. It's linked in tgik.io/notes. And I think that is, all of our news of the week. My goodness, that was a while. All right. Let's move on. So, Happy glossary. The first thing I want to do is I want to bring up the idea of ClusterAPI and what it does. We're going to do a little background. I am totally using Compiz. We're going to do a little background on ClusterAPI. We're going to talk about what it means. Then we're going to play with it. And then we're going to play with it in a way that is local to my machine, which will be kind of interesting. And we'll also talk about like why that is interesting to me. So let's get started here. So the first thing I want you to know is that ClusterAPI is part of the sigs.k8s.io stuff. And y'all might notice that that's actually pretty similar to the way that you've all seen this documentation, the kind documentation. Very similar thing. We're using that GitHub web hosting mechanism to actually host the book for ClusterAPI, right? Same thing for kind, right? So if you go to kind.sigs.k8s.io, that's the documentation for kind. If you go to cluster-api.sigs.k8s.io, this is the documentation for ClusterAPI. So introducing ClusterAPI, first let's talk a little bit about like what, and I imagine, actually I'm curious, let's do a poll. I would like for you to say yes if you're familiar with ClusterAPI to some level, and no if you're not familiar with ClusterAPI at all. Like coming to this with a completely fresh mind, right? No. If you are coming to this with somebody with some understanding of it, say yes. All right, cool. Yeah, it's Drew Lamatti. Wow, okay. Just the name. I think we're leaning a little bit more toward people who understand it a little bit, or maybe have some deep understanding of it, and some folks that don't have anything. All right, so if you're going to dig into it, ClusterAPI, this is definitely the place to start right here in this book, clusterapi.sigs.k8s.io. But let's talk a little bit about it and take a look at how this works. So what I'm going to do here, I'm going to flip over to my next screen here and get the terminal going again. And we're going to go ahead and kick up a cluster. So clear, make this bigger, make the font bigger, TGI, that's probably too big. All right. Kind create cluster config. So what I'm doing here is I'm actually going to go ahead and start up a Kubernetes cluster on my local machine using kind. You've all seen me do this quite a few times. This is going to be a single node cluster, and I've named it Cappy. And then I want to look at the configuration of it real quick, and then we'll kind of play with the with how it works. All right, so cat. This is my configuration for the kind cluster that I just created, and you can see that really all I'm doing is I am mounting in the Docker socket into that control plane node. Now, probably not a great idea in general to do that, and we've talked about why. If you're interested in understanding more about why, feel free to follow me on Twitter. I spend a lot of time yammering on about it. But what this will allow us to do is it will make it so that this control plane node can be used to effectively play with and test ClusterAPI. Now before we get into that, what I want to play with is one more thing before we get to that part. Right? So to understand a little bit about what ClusterAPI is, let's go back and talk about, just briefly, about what a deployment is. Right? So let's say kubectl run test image equals nginx replicas 3. Actually 1, because, well, let's just leave it blank. Okay. So what this is going to do is it's going to create a deployment using the nginx image from Docker Hub, and it will submit that deployment straight up to my API server, and that's where we see the output deployment apps test, right? And so now if I do kubectl get pods, I'll be able to see that my nginx instance is running, and if I wanted to scale it, right, kubectl scale deployment 3, I can go ahead and scale it, and I'll be able to see that happening kind of real time. If I wanted to reconfigure it, if I wanted to change the image that was underlying it, if I wanted to do any of those things, I could actually interact with that deployment object and see that change happen over time, right? Well, what if we took this idea of deployments and extended it to understand sort of the idea of machines, right? Maybe I want a deployment of machines which are going to be the workers for a Kubernetes cluster. Maybe I want to be able to ensure that those machines I have some ability to understand when they're running and when they're healthy, when they're not healthy. I have some ability to understand how to join these nodes into a given cluster. You can see how there's like individual pieces and parts, just like there might be as part of an application that is deployed inside of Kubernetes. There's different configuration pieces and different functions that I would want for machines to handle, just like there are different functions and configurations of given pods that might make up my application. Right? The ability to scale it up or scale it down, all of those things are pretty interesting to me when I think about the way applications work. So ClusterAPI is the idea that we might be able to actually take all of what we've learned from managing, empirically managing or imperatively managing infrastructure at like the application layer and apply it more at the infrastructure layer. Right? So just like we can do this here, where I just spun up a new deployment and I've scaled it up and I've scaled it down, and I can delete it and I can reconfigure it and I can do all of those things just by modifying the actual deployment object. What if I could do that stuff with machines, virtual machines running in some IaaS somewhere? Or in our case, containers running on my Docker daemon. That is basically the goal of what we're trying to do with what's trying to be done with ClusterAPI. Oh, hold on 1 second. And there we go. All right. I'm using, what is it? It's like a Dell or something. Like kind of a big, powerful Dell. They just recently gave me a boat anchor. It's like 16 inches full of Dell. In case wasn't using containerd, the pods would be scheduled to the host Docker. I don't know. That's mean of kind. Leigh, are you talking about kind? Because if that's true, then you're right, right? But if you think about it, really, the fact that it is still var lib, the fact that it's still var run Docker is actually somewhat orthogonal, right? So kind does use containerd to implement them, but kind actually creates one containerd instance per container, if you will, right? So every node has its own containerd. If they were in conflict, what we could do is just move the Docker implementation off to another directory, right? So that we were actually using the underlying Docker implementation. So that's a good point. Exactly. Yeah, that's a good point. All right. So that's what kind of the goal, right? Is to make it so that we can manage the lifecycle, create, scale, upgrade, deploy, and destroy of Kubernetes conformant clusters using a declarative API, and to work in different environments, right? To be able to deploy these things into AWS or Azure or GCP or Docker in my case. To define common operations and to provide a default implementation to what those Kubernetes clusters are, right? And give us the ability to modify those defaults, right? If you have a set of defaults, like obviously I would want all of my nodes to be, webhook authentication true, which means that any call that's coming into the kubelet API would have to be authenticated with the API server, right? But I want some mechanism by which to define those things, right? And fortunately, we know that we already have a sort of a tool for that, which is called kubeadm. So this is actually extending the work of kubeadm, and we'll talk a little bit more about that. So to reuse or integrate with existing ecosystem concepts, right? So again, kubeadm already exists. We probably should extend that. We already have the idea of, we already have some kind of repeatable ideas in different cloud infrastructures of a machine that is true everywhere. So maybe we should just take that one and run with it. To provide a transition path for Kubernetes lifecycles to adopt ClusterAPI. This is getting there. I don't think it's completely there yet. But they also go through the non-goals, and then they talk about where community is and that sort of stuff. So that is a quick introduction here are some pictures that kind of describe what's happening here, right? So we have our management cluster, and this is the cluster that I just spun up. And inside of that cluster, we're going to deploy three things. We're going to deploy a ClusterAPI controller, a Bootstrap provider, the thing that will turn a machine into a Kubernetes node. And then we're going to deploy an infrastructure provider, which is actually going to be the thing that ClusterAPI uses to go and talk to, right? So like, what is your infrastructure that you're going to go talk to? Are we targeting AWS? Are we targeting bare metal? Are we targeting Azure, VMware, any of these individual places? Like, that infrastructure provider is going to be unique to whatever our target is. So in my case, I'm actually going to be deploying CAPID, or ClusterAPI, for Docker, because that is actually the infrastructure that I'm going to use to create these machines and networks. And again, you can kind of see from this diagram, there is this overarching idea of a cluster, which makes sense, right? That cluster is represented by all of the nodes. All of the nodes need to have some idea of what represents the entire cluster, so they can join them, right? So kubeadm join, that we need to know what the IP address of the API server will be, or what the load balancer in front will be. We need to have a token that allows us to join a given node to that cluster. And perhaps there are some other consistent configurations that we want to actually make, right, with individual within the nodes, within a particular node group even, or within a machine deployment. And we're going to play with these things in person. Cloud provider CAPI functionality will provision VMs on new raw VMs as well. Yeah, that's in fact what it does. Yes, that's exactly what it does. So the cloud provider, so what happens, so there's three responsibilities here, right? So there's the responsibility of ClusterAPI. And ClusterAPI is responsible for defining those generic terms. What is a cluster? What is a machine? What is a machine deployment? Those sorts of things, right? Then we have a Bootstrap provider, which is like, once we have a machine, how do we turn that machine into a cluster? What is the glue that brings it from just a machine running in AWS into a member of a cluster? And then we have this infrastructure provider, which is, how do we get the machine? These are kind of out of order, to be honest, right? So in ClusterAPI, when I create a machine, that when I say go ahead and create this machine, there's a series of calls that there's a relationship with the infrastructure provider in which it will go out to the infrastructure endpoint that you've described. In my case, Docker, could be in your case AWS or vSphere, and it will say, give me a new machine, and I will, and I'll take the metadata associated with that machine and bring it back, and allow my Bootstrap provider to understand it so that it can go ahead and configure or manage that thing. Same thing with ClusterAPI, right? So if I scale this thing up or scale it down, if I wanted to create more machines or remove some machines, then that infrastructure provider will be responsible for understanding how to implement that call, right? If I scale it, I'm scaling the generic idea of a machine deployment, but the calls to AWS to make new machines will be coming from the infrastructure provider. And when they show up inside of my cluster, I know that worked because of the Bootstrap provider, right? I hope that makes that a little bit clear, what's happening there. Now, let's get into, I think, kind of the fun stuff. So we have different controllers, and actually if you wanted to dig into a little bit more about like what the actual controller is doing, right? So these are the Bootstrap controller, the cluster controller, the machine controller, machine set, and node controller. These are all the actual controllers that describe like that API, right? So the API, or they implement that API. So when you say I need a new machine, just like, let's back it up for a second. If we look at this machine idea, right, this machine could be effectively a pod. So when I deploy a new pod inside of Kubernetes, some stuff happens, right? For example, if it's not already scheduled to a node, then the scheduler will see that pod isn't scheduled to a node, and will do its work, right? It will go ahead and associate that pod object with a node object, and then as soon as a node sees it, it will actually instantiate that pod. Well, the machine controller is responsible for a very similar set of work, right? Machine controller says, oh, I see that there's a machine that's been requested, but it doesn't look like it's actually associated with a what do you call it, infrastructure provider yet. So we should probably get on that, and et cetera, right? So this is actually, how the relationship between these things actually work. So here's the infrastructure provider telling us which infrastructure provider to use to implement this particular node, and some information about it, right? Like what size is that machine, what's the provider ID, any other kind of metadata that might be interesting about that particular piece. And then we also have some status objects like Bootstrap data. Where did we get Bootstrap data from? We got Bootstrap data from the Bootstrap controller, right? The kubeadm configuration associated with this particular node is actually generated by the Bootstrap controller. It does not create EKS clusters, AKS clusters, or GKE clusters. It creates machines and deploys Kubernetes on top of them. That's correct. Now there is actually some work on the idea that, so right now it doesn't actually create EKS clusters. Because if you think about it, like it wouldn't really provide a lot of value on top of that abstraction, right? Like this, the goal of this is to provide an abstraction where you're actually getting straight up upstream Kubernetes in a very configurable and flexible way and deployed on your infrastructure, where your infrastructure is. You can do this in AWS, in Azure, in vSphere, on bare metal. It really wouldn't matter. But that is correct. You're correct, Joe. All right. So let's go ahead and get started. I think this will be a fun part. So inside of the quick start, we actually have some ways to actually go ahead and get things deployed. Now, in my case, I'm going to use Docker, and we're going to talk about a little bit why. And in fact, let's just talk about that now. And then we'll go ahead and get started and get things deployed and start playing with them and doing that sort of stuff. So the reason I'm using Docker to deploy this stuff is the very same reason that I use Kind to create my Kubernetes clusters. Like, for me, as an engineer, the most important, the most valuable way that I can get my hands on a project is by being able to play with it, right? I learn more about Kubernetes by playing with it, by tearing it apart and configuring it in different ways and understanding how different pieces work, than I will ever be able to learn if I had to actually pay for that in AWS or in GKE or in these other environments. Now, I do have an AWS account and I have a GKE account, and my company's fine with like paying for me to deploy those things there. But really, like, it means that for me to, I would have to take, I'd have to like jump into those environments. I'd have to make sure they're secure. I'd have to like go through all of this headache. And in reality, like all I can do with Kind and with those sorts of things, I can just run this stuff on my local machine. I can tear it apart. I can, especially with Kind, I can actually go ahead and build my own node image. I can put in logging statements. I can tear it apart as much as I want. And you've all seen that kind of happen over time inside of TGIK. Every time I actually, I'm on TGIK, I'm almost always using a Kind cluster. And that's the reason, right? It allows me to interact with it locally and to play with it and to troubleshoot and figure out how Kubernetes is working or not working, all right there in my own local machine. It really lets me learn a lot about that application. Now, when I want to go debug inside of a production environment or inside of one of my customers' environments, obviously I can take the knowledge that I learned locally and apply it to those environments as well. So speed is another big one. But it really lets me, like tear all the parts apart, put all the Legos on the table and figure out like can I put them back together on my own? Do I understand how the system works? And what are my questions, like in digging it through? And this actually applies directly to why I'm using Docker in the ClusterAPI model. If you think about it, ClusterAPI is like even more kind of like a very complex system, right? We're using it to interact with and manage infrastructure provided by some IaaS provider. So how can I learn more about the API? How can I learn more about the way to configure or to extend ClusterAPI, right? In a consistent way that is just local, that I can actually use to troubleshoot it. Now, ironically, I guess unironically, this is actually the same reason why ClusterAPI provider for Docker exists. I was talking to Chuck Ha, who's one of the contributors of ClusterAPI, and he says the reason that this is actually what they use ClusterAPI for Docker for pretty consistently, which is basically running the test against ClusterAPI, right? When you're making changes to controllers, these controllers that we talked about over here, the Bootstrap controller, cluster controller, machine set, machine deployment controllers, as you're modifying the code inside of these controllers, how do you ensure that you haven't broken the world, right? This is very similar to the way that the reason I like Kind. If I want to modify the code in kubeproxy, I want to be the only one looking at that code in kubeproxy inside of my environment first to prove that it works the way I expect, right? Make sure that I can build confidence in the way that this works. And with ClusterAPI provider for Docker, I can do exactly that, right? I can go ahead and ensure that the change I made to my Bootstrap or cluster or machine set controller is actually doing what it's supposed to do. I've actually solved my problem without having to, push this thing up, having it show up in having to go through CI/CD. I'm happy for it to go through that, but I want to prove confidence to myself that it works before I actually ship that out. So that is the thing I really dig about this, and this is why I'm using Docker. So because you can play with it, and that's the important part. So I've gone ahead and created this cluster, and I've already got my configuration. And so the next piece I want to do is I want to go ahead and install ClusterAPI. And so here I am grabbing some components from the wild internets, and I'm going to go ahead and apply them. So this is actually going to install the generic API. Let's do that. kubectl apply-f. Oops. Too many kubectl applies. We can see we're talking to the CAPI cluster. And we can see in the output here what's being defined, right? We can see that there is a new namespace called CAPI system created, and that we have this now, and we're defining a custom resource definition for clusters, for machine deployments, for machines, for machine sets. We're actually giving a CAPI election leader role, which is a role that's being created that allows us to determine which pod is the leader. We have a cluster role for a CAPI manager role. We have a role binding associated with that leader role that we just created, and then we create a deployment, which is the CAPI controller manager, right? So now if I do kubectl get ns, I can see CAPI system is now created, and kubectl get pods -n CAPI system. You can see our controller is running, and if I do kubectl get actually API resources, let's look for cluster. Here's some new here are the new resources that have been defined by that generic by that ClusterAPI component. Now it's not backed by anything, right? I could define a cluster here, but nothing would happen because there's a whole bunch of stuff still missing. So let's go back and look at what that stuff is that is missing. This is for v1 alpha 2, I believe, yeah. So the next thing I want to do is I want to go ahead and grab the ClusterAPI Bootstrap provider, capbk. We'll go ahead and apply that one. And here we see we're defining some new custom resource definitions again, right? We now have an object called kubeadm configs. We have an object called kubeadm config templates. We have Bootstrap cluster defined. We have a leader election again, a proxy role, a manager role. Yikes. Looks like I'm back up. Sorry about that. I think maybe the internet just bounced here for a minute because I was still connected to it and it just kind of dropped and went away from me too. Are you all back? Can I see you again? All right, cool. Sorry about that. That was really odd. Everything kind of just hung up. So hopefully we don't run into that some more. All right. So we got our new namespace. We got capbk created, and we can do kubectl get pods -a. Oh, that's not what I want. -n cap. And we can see our Bootstrap provider is running. Okay, so that's now working. So let's go ahead and deploy the next piece here, which will be the infrastructure provider for Docker. And again, we're going to be able to see a bunch of stuff get deployed. We're going to have our provider components. We're now defining what a Docker cluster is. We're defining what a Docker machine is. We're defining Docker machine templates. We have our manager role. We have a leader election role, just like before. All that stuff is still there. And you're still there too, which is awesome. That was really weird. Anyway, so kubectl get ns. So we can see the capd system being created. If this were AWS or vSphere or Project Pacific or any of the other infrastructures that we could use, then we wouldn't see capd here. We would see like cap A for Kubernetes for AWS, cap V for vSphere, cap what is it, Azure, cap Z I think it's Azure. Anyway, but you would have a different namespace for that particular provider. Kind of neat one. Capo, yeah. OpenStack could actually use a little more love, to be honest. I don't think that it's actually getting a ton of love, but like the other ones are actually all kind of. AWS I think is probably the most mature, and then like the other ones that follow after, like vSphere is probably after that, and there's a few others. Azure is actually Mr. Stephen Augustus does a ton of work on the Azure stuff, and that one's actually coming along really well as well. So like, yeah. So now what we can see is that we've got our administrative cluster up. Let's go ahead and see if we can create a cluster on Docker. So the way we're going to do that first is we're going to go ahead and we're going to deploy these things. So the first one we're going to deploy is the thing that defines what the cluster is, right? So let's go ahead and grab that. And inside here, what I'm actually doing is I'm defining the cluster in two different providers, right? I'm defining what the cluster is in the cluster implementation, and I'm providing in the ClusterAPI implementation. That's what this one is, right? And then down below here, I'm also defining I'm defining this specific cluster with the infrastructure provider, right? I got to define it in both, but it's a lot of moving parts. So let's go ahead and do that. Actually, I think I have them here. So copy kind. So I'm going to go ahead and create a namespace called C1 for where this cluster will be. I don't want to put it in my default namespace. So we'll do kubectl apply dash create the namespace, and then here's my cluster YAML. And again, you can see, right, I've got a cluster defined, and inside of here I'm just really providing the most simple outcome, right? Like this is the pod CIDR that I want it to use. I'm giving it a name. It's going to be deployed inside of this namespace, and for the infrastructure reference, it's going to use this Docker cluster named C1. And again, I'm defining what that is just down below, right? So that we don't have anything missing. So we'll go ahead and apply the cluster. And if I do kubectl get cluster -a, we can see that now there is one provisioned. It's there. We see it. But do we have any machines? Kubectl get machines -a. No resources found. Why not? Because we haven't defined any. Because we haven't defined any machines yet. What happened there? All right. So let's go ahead. So now that we actually have this overarching idea of a cluster, let's go ahead and define things that would be associated with that cluster. First thing we're going to define is the first machine, the CAPI Quick Start Control Plane 0. So this is like the first actual control plane node, right? So let's go ahead and define this guy. And again, I've already got that manifest copied in locally, so we can see CP0. This is the configuration of that, right? So we've defined the actual name of the machine, CP0. We're going to put it in the C1 namespace. We're calling it part of the same cluster that we created, the C1 cluster. Here our specs get a little more interesting, right? We're giving it the version of Kubernetes that we want to deploy. We're giving it Bootstrap configuration, because obviously we're going to need to bootstrap this node. So we're going to associate that not just with an infrastructure ref, but also with a Bootstrap configuration reference, right? And so the kubeadm, this is going to be kind kubeadm config, and the name of this is going to be CP0. And that means we have to define those things, right? So we have already defined the cluster, so we don't have to define that at the infrastructure layer, but we do have to define the machine, because this is going to be a single machine all by itself. And here in a minute, we're going to play with a deployment, which is multiple machines, but we'll play with that in just a moment. So here we're actually defining the kubeadm configuration that will be used for this particular node. Now this is where things get slightly interesting, because we are going to be using the Docker implementation. We're going to do a couple of things in here, right? So we're going to set the init configuration, node registration, kubelet extra args. So these are the extra arguments that I will pass to the kubelet that is associated with this kubeadm configuration. And in there, I'm going to pass, I want eviction to be tuned in this particular way. I want nodefs and that sort of stuff. I want the cluster configuration controller manager to enable host path provisioner true. Right, so I'm passing extra configuration to the controller manager, and I'm actually handling the init configuration for this specific kubelet also right here in this kubeadm. And this is sort of the flexibility of kubeadm. I can actually configure any number of things inside of kubeadm in this case. So let's go ahead and apply that. CP0. And we can see those three resources were created. The kubeadm config, which is part of Bootstrap, the Docker machine, which is part of the infrastructure. So that Docker machine that we create, this would be like an EC2 instance. The kubeadm configuration would continue to be on the cluster just like you see it here, but if we were pointed at AWS, instead of a Docker machine, you would see an EC2 instance, right? And then we have that generic machine object that has been created, that thing that will be managed, that we will be managing the lifecycle for. So now if I do kubectl get machine -a, we can see that it is actually provisioning a machine for me. Make sure y'all are still with me. So, can you not see the screen share? Okay, that was kind of alarming. Maybe refresh your screen, Jack? Oh, okay, cool. All right. So we're seeing a machine get provisioned. And now we see that it's running. And it says Docker C1 CP0. So now if I do Docker PS on this machine, I should be able to see that running. Right? So that is my C1 CP0 instance, and it's running version 1.15.3, because in this case it knows that the image, when I provided that that version, it's actually going to pull the kindest node of that particular image. So we're reusing components from another project, the kind project, to go ahead and to stand this up, right? So we're using kindest node, and we're actually configuring it using ClusterAPI instead of kind, which is pretty cool. And we've got our first instance up. Now there's also another instance that got created, the C1LB, and this is because in many cases people want an HA control plane. They want multiple nodes, right? They want multiple control plane nodes, and so the kind provider the ClusterAPI provider for Docker knows how to implement that, and it implements that load balancer under the covers for us. In ClusterAPI provider for AWS, it uses an ELB for this, right? And so this implementation is actually a part of how this all works. Mo, not quite yet. So Mo, this is actually mostly really focused on just trying to solve the Kubernetes problem. It's not really trying to solve the problem of how do you consume those other resources that may be available to you inside of Kubernetes or inside of AWS. Sorry, it's just really trying to provide that that way of implementing the Kubernetes cluster itself inside of those environments. All right, so let's go back to our instructions here. We've already done this part. Our next one, so if we go ahead and do kubectl get machines, and we can actually even see the machines that are associated with just a control plane. So let's go ahead and do that. -A. We can see our instance running just like we said before, so that's working good. And now we can actually grab the kube config of that, right? And so let's go ahead and copy this out. Okay. So what this is doing is I'm saying I'm using kubectl inside of the namespace C1 where I created my cluster to grab a secret that was generated there, right? So when I created the cluster, as part of creating that cluster, it actually generates a kube config in the administrative cluster that I can use to download and then interact with that lower cluster, right? So if I do kubectl get secrets -n C1, I can see the secrets that have been created. There's a secret for the CA, there's a secret for the etcd component, for the kube config that has been generated, for the proxy, and for the service account to be generated. And these secrets are important because if you think about standing up any Kubernetes cluster, most of these things are used or copied to different API servers as they're generated, right? So these represent sort of those secrets that get copied around. The kube config itself is actually more of a convenience than a requirement. We don't necessarily need that kube config to be inside this cluster, but because of just mere convenience, it makes a lot of sense for it to be there, right? For us to actually be able to understand that things are working. But the other ones, the etcd CA is super necessary. The cluster CA, we want to make sure that all of the control plane nodes agree on what that CA key and public key are. Same for etcd, and same for the front proxy, and the same for the service account token key, right? Like these certificates, super important that all of the control plane nodes agree on what they are, or things are not going to go well for the cluster. Joe has a question. With management cluster having so much power, centralized admin creds, infra creds, do you think there are any different security practices that are warranted around this? I think, in my opinion, you would keep this one pretty locked down. You wouldn't run workload clusters on your management cluster. You would actually only you would be using it only to instantiate and create Kubernetes clusters, right? But this isn't a Kubernetes cluster like any other cluster. I would not like put, my WordPress deployment on top of the cluster that has my ClusterAPI provider configuration inside of it. That would be a learning lesson, I would say. Does that answer your question, Joe? What Docker image are you used to provision the Docker node? So the Docker image that was used is actually defined by the ClusterAPI provider for Docker, and the one it used to stand up that control plane node is actually kindest node v1.15.3. And if you've ever played with kind, then you'll notice this pattern, right? This is actually the pattern that is used to stand up the kind cluster as well. So these images are maintained by the kind project, and they have all of the bits integrated with them to be able to stand up and manage a Kubernetes cluster. So inside of them already, they'll have the kubelet, they'll have kubekettle, and they'll have kubeadm all already installed on that node, and they'll already have kind of the necessary bits to make sure that that image can be a working kubelet node. What are the options around this in bare metal environments? So that's a fascinating question, and I'm going to come back to it, Josh. But we're going to come back to it. All right, so here we are. So let's go ahead and do the next piece, because I totally want to put, that's the thing I really want to talk about. Oh, okay. So we have our kube config. So let's try this. Export kube config equals C1 kube config, kubekettle get pods -a. And we have, this is our kubekettle get nodes. Right, so we have our C1 CP0 node. We see it's not ready. This is probably because there's no network implementation already deployed. We see it's running at v1.15.3. So we actually see that this is the cluster that I created using ClusterAPI. So I'm going to unset my kubeconfig variable again. Kick back to the API cluster, and then we're going to go ahead and we're going to deploy Calico, because why not? Actually, I'm just going to do this. So there's all of our Calico stuff being deployed. And if we do our get pods-a again, we can see Calico deploying. This is happening inside of that guest cluster node. There's only one node right now. It's like the one control plane node. So while that's happening, let's go ahead and kick up the other thing. We're going to create a machine deployment. Click over to the Docker one. And again, in here, we're going to break this down into like what's actually happening, right? So we're going to create a couple of different resources. We're going to create a resource that defines the machine deployment using the ClusterAPI interface, right? Inside, we're going to name this C1 in our case. We're going to give it a node pool. Or we're going to associate with a node pool. I think that actually might be extraneous. And then we're going to give it some labels. We're going to give it a Bootstrap configuration. This is going to be called worker. We're using the Bootstrap interface to describe that relationship, just like we did with this control plane node. Only in this case, right, we're actually doing this across a bunch of different machines. This is a template spec because this is a deployment. So we're saying we want to templatize that CAPI quick start worker configuration across the set, right? Same thing for the infrastructure piece. We're going to use a Docker machine template to describe the configuration of each of the Docker machines that will be part of the worker configuration, right? So we have to define a Docker machine template, which is blank. There's nothing special about it. It's going to use all the kind of built-ins, and we're also going to have to define the kubeadm configuration, in which again we're passing some extra arguments to the node registration for this guy, and then we also, this is all I'm sure extraneous. So this is actually also configuring the controller manager on the worker nodes, which clearly won't work, won't do anything for us, but it's defined the same way here. So let's go ahead and do this. So let's go ahead and get this deployed. So let's take a look at the nodes YAML. This is actually where we're defining that same thing that we just talked about, right? We've got our machine deployment. We're putting it in the C1 namespace. We're going to call this machine deployment worker. Probably could call it workers. We're associating it with cluster name C1. We're giving one machine, and we'll scale it up and scale it down and play with that sort of thing. We're going to go ahead and define the Bootstrap configuration that will be associated with it, and we'll create the infrastructure configuration that will be associated with it. Down below here, this is the Docker machine template, nothing special in here. And then here's our kubeadm configuration template, just like we saw before, with our join configuration this time, because this is a worker node, so it will be kubectl join, and our cluster configuration here being passed down, although it will be ignored on the worker nodes. Let's go ahead and apply that. Now if I do kubectl get pods dash a kubeconfig equals C1, so we can see Calico node is coming up. The Calico controllers are running. Get nodes dash kubeconfig C1. So we have our C1 CP0 is in a ready state. C1 worker is coming on. And now C1 worker is in a ready state. And so now we've actually created our new machine deployment. So, just like we saw with our deployment earlier, what if we were to scale the number of workers we have running inside the cluster, right? So we do kubectl get machine deployment dash a. This is the name of our deployment. And if I did kubectl scale deploy machine deployment worker dash, pick our right namespace, dash nc1 replicas 3. Then just like our deployment, that scaling function has effect, right? So now if we do kubectl get machine dash a, we can see we have other machines kicking up, right? That's our first C1 worker, and now we're actually provisioning 2 more, just like we did with deployments. So in this case, we're not interacting with pods. We're interacting with infrastructure. We're saying I want 2 more machines, and the infrastructure provider says, okay, I'm going to go create 2 more machines. In our case, this is represented as spinning up a couple more Docker containers. But in AWS or in some of these other environments, that might be represented by creating another machine. So, and now we see our 3 workers running. And if we do get nodes with that C1 kubeconfig, you can see they're still coming online, and they're ready. So now our guest cluster is fully ready. Now, a couple of other neat things that I want to talk about before we play with it and start breaking it and doing that sort of stuff. One of the things I want to talk about is the fact that this child cluster is completely autonomous from the parent cluster. I could destroy the administrative cluster, like the CAPI cluster. I could make this one go away, and this cluster down here would continue to work and be just fine. Nothing is going to be managed with it. Yeah, in fact, it would actually just be cluster autoscaling. And there is a ticket open to actually make cluster autoscaler work with ClusterAPI. It's not quite done yet, but at the moment, this is completely, it's got a lot of autonomy. Now, the problem, of course, is if the administrative cluster were to go away, it would mean that nothing would be taking care of the life cycle of these machines. If a machine died, there would be nothing to reinstantiate that machine, right? So as long as the administrative cluster is healthy and working, then there is a reconciliation loop running on the control plane that will take care of that for us. In fact, let's go ahead and play with that, right? So we have our Docker PS. Actually, let's do this. Let's do our kubectl get nodes, right? And so that is the name of one of the containers running inside of my Docker instance. So I'm going to go ahead and do docker rm-f, and I've just deleted that instance. And let's see how long it takes for things to figure out. I'm actually kind of curious. I haven't played with this particular example myself, but let's see what happens. So the master report in. So I think eventually it should figure out that the worker's not there anymore. Lost webcast. Am I gone? Okay. You're freaking me out, man. Okay. Rory can still see me. Joe, can you see me? All right. Whew. I was like, no, not again. All right. So yes, the answer to that is yes. That is precisely how it works. So we've just detected that the node is not ready. You can see it going to not ready now. And so if I go in here and I do kubectl get nodes without the W, we can see it's not ready, so nothing else will be scheduled there. But now we're kind of in the long dark tea time of the soul, right? Like there's nothing that would delete that node for us automatically, per se. And this is actually a responsibility of the controller. So in AWS, the AWS machine controller is actually probably a little more robust and can handle this, but like if I go ahead and delete machine -nc1, what happens there? Get machine dash to DXNG. Oh, I'm wrong about this. It actually did. It did delete it. No, it didn't. Docker ps grep 2dx. Yeah, okay. So the machine has not been deleted. It still thinks it's running. So this is actually a failing of the Docker implementation, but this instance still thinks it's there. So let's go ahead and delete this instance. Let's see if that changes anything. Delete machine -n c1. So now if we do get machine -a, we see that machine went away, and we have a new machine provisioning. Oh, hey, and when we deleted it, it did get deleted from the cluster. So when we deleted that machine from the ClusterAPI implementation of machine, the ClusterAPI implementation made a call to delete that from the cluster. And now we have a new machine coming online. So what we just tested here was a different kind of failure. This failure was kind of interesting. So I went ahead and deleted the machine from Docker, and I don't think that anything has been implemented in such a way that the reconciliation loop inside of my administrative cluster is polling Docker to see if those machines are in a healthy state or not. So it never detected that it's not in a healthy state anymore. It never tried to delete it. And that's probably just a function of not having been implemented yet. But if we do actually delete the machine itself, right? Kubectl get machine -n c1. If we delete this machine, bnl59, kubectl delete machine -n c1 bl59, kubectl get nodes -n -kube-config. We can see that machine got deleted, right? That machine has been deleted, and here in just a minute, we should be able to see a new machine replace it. And there's that new machine coming in to replace it. So the logic inside of the controller for handling the reconciliation of I have requested that there be 3 workers, and the reconciliation saying, well, if you delete it this way, then I'll definitely make sure that I get you 3 workers. So that's one way of actually handling this problem. So All right, so that works. We can actually play with those sorts of things. Let's do that. That's a great idea. Let's do that one next. All right, so the first thing I'm going to do is I'm going to do this. So we got kubectl get kubectl version. We can see our cluster. First thing, you know what? If we're going to upgrade some stuff, we should probably like add a couple more control plane nodes. So let's go ahead and do that. So other, and what this is doing is, let's just take a look at these manifests real quick. So inside here, I'm actually going to go ahead and create a couple other control plane nodes. I'm associating with the same cluster. I'm using the same version, all that stuff, right? So I'm going to do kubectl apply -f. And I've created another machine, another Docker machine, and another Kubernetes config. So now if I do kubectl get machine -n c1, this will actually turn my control plane node into an HA control plane node. And this is important because when we do upgrades, right now it means rip and replace. It means replace that node with a new node. All right, so now we got our new control plane node running 2 nodes. And here in a second, we're going to be able to see all 3. Got 2 masters. Got 3 masters, not quite ready yet. Okay. So we have 3 master control plane, all working, all up and running. So now, let's go ahead and handle this. Does delete follow the same protocols? It does. Of drain cordon. Yep, it sure does. Yep, and in case, yeah. Deleting of a node definitely takes care. Does handle that. If you scale it down, like if it has some idea of how that's happening. If it's just a straight hardware failure, like in my case, I just straight up like removed that Docker machine from the earth, there's no way that it could understand how to do that. But so in that case, when you hit delete, it deletes right away. Where if I tried to delete one that was already running, then you will see that it would go not ready. It would become cordoned. Things would schedule to other nodes, and we would delete them. But let's do that thing with Docker nodes. Let's do that thing with upgrade as well. So I think ClusterAPI upgrade. This is another tool that's currently hosted on VMware, written by Mr. Andy. I guess I have to build it. So let's just put clone, copy. Cool. Yes. Okay, cool. Oh, they want you to check it out. Let's do that. Git clone. CD ClusterAPI upgrade tool. Make bin. And I'm building it up against master, so we'll see if this works out, but it should be fun if it does. But what this will do is it will actually go through, it did work. So, bin, ClusterAPI, local bin, okay. All right, so let's go back to our documentation. So try this out. So let's go ahead and do it. And then it has this example of the command to run to actually do this thing. So let's go ahead and do that. That's 16.4. C1. C1. Okay. So if I run this, then what this will do is it will go through and upgrade the control plane to a new version. So let's go ahead and try that out. And it really gives me a lot of information. So what it's going to do, let me go ahead and pick up another screen here. See TGI. Get events. Send that back down a little. Machine -A. All right. Okay, you're back with me. So what's happening here is it's going to go ahead and create a new CP0 node and replace that one, right? And so this is actually going to make all the cool kubeadm commands calls to delete this old etcd member from the cluster to bring on the new etcd member of the cluster. So we're going to see that happen over time. So CP0 test is working, and then we're going to see CP0 test get delete, right? So in this output, let me actually just make this a little smaller so I think makes it a little more readable. I hope that that's at least legible. So we can see what's happening is that etcd was in a healthy state. We see all three members. Now we're creating our new member, the CP0 test. We're doing a get pod over and over and over again until we were able to actually see that new node show up. And once it shows up, we're going to go ahead and do some other cool stuff to it. So we say we found the node, waiting for the API server and etcd to be healthy on that node. We can see only that new node. We don't see that in the cluster yet. Okay, so we found it, right? So we found our C1 CP0. We deleted the old member and we're replacing it with a new member. We're running member remove of the one from CP0, and then we're going to delete the CP0 machine, and we're going to wait for it to be deleted. So here's that etcd kettle command, like what actually was run. And we go back over here, we can see the kubectl get nodes -- kubeconfig equals equals C1. So we see we have 4 masters running here. We're waiting for the machine to be deleted. So now we see it's basically in accordance state. It's ready, but scheduling disabled. So again, this is kind of validating Joe's point, and I think Maddie's point as well. Right, so we see the machine being deleted slowly and carefully. It will eventually go away. So Maddie, are you in Atlanta as well? All right, so we've just replaced our first node, and we can see the version of that node is 1.16.4. And so now if we go back to our log on, I'm returning to you, don't worry. Let me know when I'm back. I'm back. Are y'all there? All right, sorry about that. That's frustrating. I wonder if it's actually my wireless, because this is a relatively new laptop, and Linux being Linux, you know, it could be the wireless. I'll have to try and figure that out, but you know, at some point. Probably not today. So we got our new master up, waiting for the old one to go cordoned. Oh my gosh, yeah, you should go to sleep, Waleed. Thank you so much for your time. You enjoy your weekend as well. Thank you very much for tuning in and like catching it. I'm sure that you'll be able to follow along for the rest of it as long as my wireless hangs out for just a little bit longer. After this is done, we're going to just upgrade the nodes, and then I think we're probably going to wrap. So have a kicking weekend. I don't think it is. LSHW. But I have not had problems with it so far. Anyway. But more to the point, how are we doing on those nodes? So we got CP1 now in accordance state, about to be deleted. And gone. All right, so now we just have one more master to do. Okay, things are working. Well, I talk about cluster kettle. I might, but I'm not really pivoting anything, like which is kind of the biggest killer value of cluster kettle at the moment. So yeah, you know what? Let's talk about it because it's a good point. So. Cluster kettle is a thing that has like come and gone from the ClusterAPI project. Let's talk about what it is. So and it's coming back like in this next version, but it was like there was for a brief version, cluster kettle had kind of gone away, and now it's returned. So cluster kettle actually provides some pretty interesting functionality about the way that we think about that administrative cluster, right? So if we were going to spin up an administrative cluster, we might do that initially inside of like a kind cluster, right? We stand up our kind cluster, we deploy all the API objects, we configure them, we deploy a first cluster inside of AWS, and then we might want to make that new first cluster in AWS the new administrative cluster. And so ClusterAPI has this concept of like cluster kettle init, This is the way that you turn a Kubernetes cluster into a cluster API provider cluster. And this is actually, you can also do a thing like create the first workload cluster, which is what we're describing here. And then down below, we can also, I believe, is it not doing pivot? So we have cluster kettle upgrade, cluster kettle delete, cluster kettle move, which is where we basically move all of the objects in our administrative cluster running on our kind cluster, which is meant to be somewhat temporary, into the kind of long-lived one that's sitting up inside of our AWS or inside of our infrastructure provider. So these different day 2 operations are pretty neat. What I was using there to do upgrade, I was actually calling the cluster API upgrade piece myself, kind of from the command line. But cluster kettle is allowing us to wrap that, right? If we wanted to do an upgrade of the cluster API providers and possibly also of the cluster, this might be something where we could wrap this in, right? Cluster kettle delete gives us the ability to delete those API providers, so that infrastructure provider, those Bootstrap providers, all of the bits of the actual the cluster API that we've actually got running, and then to actually configure any of these components, they have that wrapper as well. So that's like all the stuff that's coming with cluster kettle, but that's going to be released in the next version. It's not in the upstream docs today, but it will be in the next version of the docs. In fact, if you look at this URL here at the top, remember the URL for the docs that I was using was cluster-api.sigs.k8.io. If I prepend that with master dot, I could see what the docs look like in master. And they look different than the ones that I'm using to do this test. So stuff that's coming, we're definitely going to be able to see in master.cluster.api, whereas like the current upstream ones is kind of a cool little URL hack to make that work. So let's see if we have proceeded here. All right, so we got our new clusters up. We got our new things working. And our upgrade was successful, but there's still something missing, right? Dang it, why do people say they're losing it? All right, so there's still something missing. We can still see that we have 3 machines here that are running 1.15.3. Does anybody have any ideas how we can upgrade those ones? Right, remember that this is part of a machine deployment. So how can we upgrade the version of Kubernetes running on those worker nodes? Anybody idea? Thoughts? Boom! Joe for the win! Machine deployment -n C1 worker. I could probably do this with patch, but you know, why? So here is my version object. Let's go ahead and kick them up to 1.16.4. And let's watch what happens. So we should actually see the nodes come and go here. The actual worker nodes should become unready, unscheduled, just like you saw on the masters. And we'll go tripping through the worker nodes and upgrade them to the next version of Kubernetes. And to do this, what we're doing is we're actually just replacing the underlying instance with a new instance operating at that new version. So this is like immutable infrastructure level stuff, right? We're not actually trying to modify the. We're not trying to upgrade them in place. We're trying to replace them with new version, with a new instance running at that new version. So since we made our change, let's do kubectl get logs -n cap d system, but without the get because it's logs. You can see the output here. If we wanted to see the log, we're saying we're waiting for the Bootstrap provider controller to set the Bootstrap data. got some other things happening. Do kubectl get machine -a. You can see a new worker being provisioned. And those of you who have played with deployments before know what we're looking at here, right? We can see that the hash of that configuration has changed, right? And so the name is not the same. And so because it's provisioning, it's actually probably pulling down that version of the Docker container that I don't have. So it'll take a minute. All right, there we go, it's working. So now we can see that worker just joined. That new worker is in place. It's about to become ready. It has to download the Calico stuff. But now we have one new worker. We need to get rid of one of the old workers. Let's pick one and put it into cordon mode. Oh, I mean, obviously there's nothing running on there. Presumably it just went cordon and delete very quickly, because otherwise that would have been somewhat disheartening. Kubectl run test image equals nginx replicas 3 kubeconfig equals c1. Running. It is going to go one at a time, exactly. I believe that the plan is to implement that so that there would be a rolling so that you could actually set the surging. I don't think it's currently implemented though, right? So if I do kubectl edit machine deployment -n c1 worker, I don't think it's, oh yeah, actually, strategy is defined. So maybe it's in there. So we've got ourselves on VSX, RC4, and H94. How should we pronounce kettle? I don't know. Oh, nice. Cluster kettle. We could ramp those up for faster machines that roll out. That's true. Yeah, I believe it. I believe that is true. So, is anyone becoming not ready? That's our new worker node of the new version. And there we go. So now we see the cordon and drain, because there's actually something on it. So before it was actually not running. Before I didn't have anything running on that node. So it's actually kind of cool. So before I didn't have anything running on any nodes. So when I actually went to go do my when I went to go kill the old node, it was just like, anything here? Nope, then delete it, right? Like it was waiting for the cordon and drain. It drained instantly because there was nothing to drain, and then the controller deleted it. So I just kicked up a little deployment of a couple of nginx instances, and this meant that it would actually have to drain it, and that's why we were able to see that drain happen. That's exactly what happened here, was the drain actually happened, drain completed, and then we killed the node and we move on. So is it on the roadmap to be able to run control plane on main cluster, but nodes on their own VMs? I guess I'm not clear on the question. Is it on the roadmap to be able to control plane on the main cluster and nodes on their own VMs? Nodes on their own VMs. I don't understand where you're coming from with that one, Dimitri. You're going to have to explain that one to me a little better. All right, so one of the questions that came up earlier, and this is an important one to me because I'm a bare metal guy, right? Like, one of the questions that came up was like, could we do a thing where we do this with bare metal? And so, in my opinion, yes, I think it is absolutely possible, and I think it's actually kind of an intriguing question because here's how this would shape up in my mind, right? We could, for example, use the tooling here to stand up Kubernetes clusters, leveraging. We could use the ClusterAPI provider to stand up and manage the control plane, and we could use it to upgrade and manage the lifecycle of that control plane, and everything would be great. And we could even use it to stand up another pool of nodes that are the worker nodes, and that's what we're seeing here, right? C1 worker, and we can manage the lifecycle of those. But when it comes to bare metal, how do we handle that problem, right? Like if I actually had a bare metal node, like say my laptop, how would I handle that? Oh, do I have it? I don't even think I have it. System, CTL, cat kubelet. Oh, okay. In that case, here's what we're gonna do. So if I wanted to create another node, let's go ahead and do that. So I'm gonna generically create a create cluster image equals kind dist node v1.16.4 name stolen. I'm doing this really just to simplify my life, right? So what I'm doing is I'm creating another cluster with a single node, and then I'm going to jump into that node, and I'm going to wipe it out, and then I'm going to join it to the other cluster. So check this out. This is going to be the fun part. We'll pretend like this is the bare metal node, right? I have gotten to the point where the node has been configured. I'm going to jump in here. First, I'm going to do this. So cd TGIK cluster copy kind. So this is my cluster. kubectl get nodes dash dash config equals C1. So I see all of my nodes, right? And I can jump into one of them. I'm going to do docker exec ti C1 cp0 bash kubeadm token create print join command. I'm going to copy that to my buffer. Copy, exit out of here, and then I'm going to do docker exec ti stolen bash. So now I'm inside of that control plane node that I created, and I'm going to turn it into not a control plane node. I'm going to turn it into a regular worker node. So let's go ahead and do that. So kubeadm reset-f. So now I have a node. It has an IP, but it has nothing running on it. If I do docker cri ps, nothing is there, right? So let's go ahead and join this node to that other node. And it's going to complain, but that's okay. And then we'll do ignore pre-flight errors. Oh. So I've already got my Bootstrap, my Pixie environment stood up. I've got all that figured out, and I've got like a way to bring nodes up to a point where they could be made a part of a Kubernetes cluster. That means they've got kubelet already running on them, or they've got kubelet already set on them. They've got the other prerequisites, Docker's already configured, containerd if you want that. Like your base configuration of that node has already been handled. And so now I'm going to join my new node, my stolen control plane node, to my cluster, right? So if we do kubectl config use context capi. Okay, so now if we do kubectl get nodes kubeconfig equals c1 kubeconfig, there's our stolen control plane node. Right? So in this way, because we're using kubeadm as the underlying implementation, right? Because we're using kubeadm as the underlying implementation, there's nothing keeping us from using kubeadm as the way that we join the bare metal nodes into a control plane that is managed by some administrative cluster. Right, giving us the ability to kind of handle that automation all the way down to the node. Like if I had a Bootstrap or a Pixie environment, I'm not gonna play with VirtualBox for you right now. But if I did, I could totally just do that. Right, I could bring up the node, instantiate it with kubeadm, and join it to one of my existing control planes. Right, so pretty cool. Let me read this question by Dimitri. Give me 1 second here. So. I meant run all child API servers. Oh, you know what? There's another project that does this, and it's called, what is it called? Gardener. It's called Gardener. Gardener does that. I don't really think that running control plane instances as pods is really the way to go. I think it's better to run them as machines. And I'm also, and coming from CoreOS, this is kind of, this is a painful thing, but like I'm not a big believer in self-hosted Kubernetes. There it is, I said it. I am a believer in using static manifests on kubelets to actually manage the control plane because I think it handles the reboot case better. But that's my own opinion, and it's born of experience from having done this a couple of times. But that's definitely my impression. I think that, and it's actually what's ironic is it's not true for everything, right? Like if I look at, I think that I'm open to the idea of the controller manager and the scheduler being a deployment running inside of a cluster, but the API server itself is such an intrinsic piece that it needs to be bootstrapped consistently and reliably every time a machine reboots. And I can get by with static pod manifest to actually achieve that. And in fact, if you look at some of the different methods that are out there for handling that problem, that's kind of exactly what they've done. Anyway, that's what I wanted to share with you all. I just wanted to play with this, and I hope that was interesting. And I know that was a lot of information, and much of it was probably helpful, and some of it was completely nuts, but that's totally what I wanted to cover. That's true. Using a management cluster is not self-hosted. So, cool. Thanks a bunch, everybody. Have a kickin' weekend. I know that I'm planning on having a kickin' weekend. I'm going to go watch Harry Potter the Cursed Child with my very own cursed child. So I'm looking forward to that. It's like 6 hours or something. I figured by then she'll at least climbed like everything that's even possibly climbable from where she's at. So see y'all next time. Oh wait, there's one more thing before I go. I forgot. Haha, I'm so proud of myself, I remembered. So next week, I'm actually going to be interviewed on KubeCuddle, which is a new podcast that's being hosted by a good friend of mine named Rich Burrows. And if you're interested in asking any question of me, and everything's on the table, like you want to ask me anything, that's the time to do it, in tech or personal, whatever, go ahead and just jump into this tweet and ask the question, and we'll make sure that we cover it in the next session. So you can see that some of the questions were pretty good. Already I just have one about malicious pods. And then the other one I really like is, I have a lot of questions. Number one, how dare you? My reply, I'm particularly proud of. I woke up like this, that's who I am. Anyway, so I look forward to seeing you all soon. So enjoy, If you're interested in that, that's on tgik.io/notes. Throw some questions in there. I'll see you all next time. Have a kickin' weekend, and see y'all later.